break-even analysis, graphing and problem solving. So we have a break-even question. Alana wants to start a business selling cupcakes. She estimates her weekly fixed costs will be $850 and that it will cost $1.50 to make each cupcake. She plans to sell them for $5 each. Questions that we're dealing with are firstly, find her break-even point, and secondly, calculate her profit or loss in this particular scenario of selling 300 cupcakes per week. So when we're doing break-even analysis, we really do have to understand graphing lines, and it's a really good idea to understand it with the graphics calculator. So we'll start off getting our cost and revenue rules. We start off, of course, we want to find out the number of cupcakes she needs to sell per week. So our solution starts with let X be the number of cupcakes sold. So we define our variable. The cost equation, cost of running this business, $850 in fixed costs plus $1.50 for every cupcake. The revenue equation, $5 per cupcake. So remember that the number of cupcakes is graphed on the x-axis and cost and revenue are both graphed on the y-axis. Now we need to be able to graph these, and to graph you need 2 points for each line. You can always start with the theoretical selling 0 cupcakes. So to find out where we start, we let x equal 0. If she sells no cupcakes, the cost, 850 plus 1.5x, the cost will be 850 plus 0. So it will cost her $850 even if she sells no cupcakes. And of course, her revenue will equal 0 because that's 5 times 0. I should have written the rule there. So the first points of the lines are given there when x is 0. You then have to pick another x value to find one more point for each of your lines, because we're going to graph both lines, and so we need 2 points to draw the straight line. Now, at this point, it's really a good idea to grab your graphics calculator. Let's put both these rules in. Y equals 850 plus 1.5x and 5x. By putting them into the graphics calculator, you get a bit of an idea of what's happening with these lines. Let's just hit graph. Nothing happens. Oh look, we get a graph. I've only got one graph. Why do I have that? I haven't set my window up right. This is going up to 10x, 10 cupcakes. Is she really going to be selling 10 cupcakes? We start at 850 for the costs here on the y-axis. We've got to get our y-axis going up much further. Let's try 1,000. That means our x-axis is going to have to go up a lot further as well, because if we're looking at costs of 1,000, how many cupcakes would you have to sell if it's $5 per cupcake, even just to make you have $1,000 coming in? So you probably want to start juggling around with your x and y axes. Well, that's looking better. At least I've got both lines now, but I'm not anywhere near the break-even point. By playing around with it on the graphics calculator, you get an idea before you start drawing your graph of what it's going to have to look like. So it's a really good idea to be really comfortable with this. Let's up our window to 400 cupcakes and, I don't know, 3,000 on the y-axis and see if that graph's okay. There we go. Now we see what these graphs are looking like. From there, we can get the break-even point. It's right here. You remember how to do that, I hope. We go into Calc, intersect, choose the first line, choose the second line, and move to roughly where they cross over. All right, this has calculated our break-even point. If we're allowed to do this on the graphics calculator, then the break-even point is when she's sold 243 cupcakes. Remember, we must round up to the nearest whole cupcake, but we do round up. So, even if we've got to graph it on paper, just making sure we've done it first on the graphics calculator is a really good idea, because now I know that my graph needs to go up to at least 250 on the X, and at least 1,200 and a bit above on the Y. So, all this was to say we've got to pick another point to graph our line up to. Now here's a hint. Have a look at the rest of the questions. If she sold 300 cupcakes per week, calculate her profit or loss. If they're going to ask you to work it out for 300 cupcakes anyway, let's pick our other point at 300, because I'm going to have to do this anyway. Let X equal 300. So anytime they give you this sort of question, we're working out the cost and the revenue for that number that they've given us, and from that we'll work out profit or loss later. So we're cheating a little bit by saying, look, I know I need to find another X point, it might as well be this one. Substitute that into both of your lines. So cost is 850 plus 1.5x, 850 plus 1.5 times 300. Now you could just use the calculator, because remember you can use calc value and say what happens when x is 300. Y1 for the cost there is going to be 1,300. Or you could work it out. 850 plus 1.5 times 300, 1,300. We need to work it out for the revenue as well. Revenue is 5x, which is 5 times 300, which is 1,500. So, later when we come to answer this question, we've now got cost and revenue and we'll be able to find the profit. But for now, we want to be doing the break-even analysis by graphing. So all of this was just to find 2 points for each line so that we can graph them. And these are nice, easy points to graph. So, get your graph paper. And your ruler. I'm going to be using a protractor. Our x-axis has to go from 0 to 300. Let's highlight these. X has to go from 0 to 300. It's got to be big enough to show the break-even point, which it is, because we checked our break-even point on the graph. So it's got to have a bigger value than that. And Y has to go from 0, because revenue starts at 0, up to 1,500. So, obviously we're not going up by 1 here. an X value, now if I've got to go up to 300, I'm just going to go up by 30s here. Why? It seems easy enough. You could go up by 50s, would be easier. But you know, there we go, X. I've got to get my Y value all the way up to 1500. So chances are I'll use 15 centimeters and make each of them 100. I might run out of space. So let's make them 200. Okay, so this is money here. This is number of cupcakes sold. Do label your axes. And put in both your lines. So your revenue line has to go from 0 to 1500. Put a mark at 0, and at 300 cupcakes your revenue is 1500. Find a ruler that's actually long enough and put in your revenue line. You've got to label that revenue. R equals, sorry, what is revenue? Revenue is 5x. You put in your cost line. The cost when x is 0 is 850. 850. And when you've sold 300 cupcakes, the cost is 1300. 300 cupcakes, cost of 1300, and you graph that line. You label that line. Costs, C equals, what is it? 850 plus 1.5x. So, this is a graphical representation of what the business could do. In this range here, her costs are greater than her revenue. She's losing money. She's making a loss. In this area here, her revenue is greater than her costs. She's making money. She's making a profit. This is her break-even point. Now you can get a break-even point approximately from the graph at about 240 cupcakes and at a revenue of, revenue of about 1200. So you can say approximately where that is from the graph. So if we're reporting on this question, how many cupcakes would she need to sell each week to break even? From the graph, we're saying approximately 240. If we checked with our graphics calculator, since we've already got the graphs in there, using calc intersect, first curve, second curve, take a guess, 243 cupcakes. Graphics calculator, 243. So it's a really good idea to check. Now, when you ask the question, which we haven't really answered yet, if she sold 300 cupcakes per week, calculate her profit or loss. You check your formula for profit and loss. We can see that at 300, revenue is greater, so she's making a profit. Our profit formula is revenue minus costs. You found the cost and the revenue already for 300 cupcakes. The revenue for 300 cupcakes is $1,500. The costs for 300 cupcakes is $1,300. So her profit is $200 if she sells 300 cupcakes per week. So there's a bunch of stuff to take in there. There's how to make a graph by checking it with your graphics calculator first and by finding 2 points. One where x is 0 and one more when there's a useful value of x. 2 points for each graph means you can graph them both and find the break-even point.